My name is Norm Miller, and I'm going to talk about how to calculate appraisal value ranges. We're going to learn a method that we can use to calculate a standard deviation on a sales comparison appraisal based on as few as 3 comparable properties using the adjusted price of each property. Let's go ahead and look at a spreadsheet. So I'm assuming you know something about appraisal before listening to this discussion. But in this spreadsheet, I'm only going to make 2 types of adjustments, one for time and one for size. I simply want to get adjusted selling prices to illustrate the technique. So the selling prices for 3 comps are shown here, and I want to know what the subject property is worth. The selling prices occurred 6 months ago, 9 months ago, 3 months ago, and with an appreciation rate in the neighborhood of 3.6%, I need to add these percentages as shown to adjust for the time trend and answer the question, what would they sell for if they sold today? So I make these dollar adjustments in time, and then I show you the time adjusted price, trying to answer the question, what would they sell for if they sold today? Next, I'm going to adjust for size. This comp's smaller, so I have to add something. This one's a little bit larger, I have to subtract something. This one's larger, I have to subtract something. I'm going to calculate the price per square foot based on the adjusted time price by simply dividing the square feet into it, and that's what you see in this cell. Simply dividing the adjusted price by the size. And then I'm going to use that times the difference between the subject property and the comp and add 7932 to comp 1, subtract 1365 from comp 2, subtract 5414 from comp 3. So I will have made 2 adjustments now, one for time, one for size. My total adjustments and absolute value are shown here. And I see that for comp 1, I made 10.3% in adjustments as a percentage of the selling price. For comp 2, only 1.4, and for comp 3, 5.8. Now again, these are the absolute sum of all adjustments. So they could be positive and negative and average out to 0, but I want to know how much adjustment thing I did in total. So I come up with this adjusted selling price. And if I weighted them equally, the value of the property would be right there, $105,054. You could round that off to $105,000. Now, if I look at these 3 comps and I say this one's the best comp, I'm going to weight comp 2 40%, comp 3 35%, comp 1 25%. I still get a pretty similar number, 105,318, but a slightly different result. And of course, it does make sense to weight the comparables that are more like the subject property more heavily. So this is our adjusted comparable prices that we're going to work with to calculate a standard deviation. So let's look at the next sheet. Again, you see my adjusted prices here, weighted equally or weighted based on these percentages as shown. Now let's go ahead and calculate the difference between the adjusted price and the conclusion of value. So the conclusion of value is like the mean, and the adjusted price is an observation. And the difference here is 1939 for comp 1. For each of these differences in each comp, we're going to square those, to square the number, and then we're going to sum those and divide by n. In this case, the n is 3. So you see the formula right here, sum divided by 3. The last step to get the standard deviation is to take the square root of it. So what I've done is I've just, in pure math, I've calculated the standard deviation right here of 1419. And then I tested my result against what Excel would calculate for that same population. And I see the result is the same, and this assumes it's a normal population. Now, had I weighted the standard deviation differences by the percentages that we have here on comparability, I'd get a pretty similar result, but slightly less because we put more weight on those properties that are more like the subject property. The only difference is that when I take the square differences, instead of summing them and dividing by 3, I'm going to weight these. In this case, I'm weighting it by B3, which is 25%. I'm weighting it by C3, 40%, and I'm weighting it by D3, which is 35%, and I'm not going to divide by N. So I weighted these differences, and you see I get a slightly smaller number now because I put more weight on a more similar comparable property. I recalculate my standard deviation, and you see that it's about 7% lower than the method above. Either of these methods makes sense. The second method, based on the weighting, might make the most sense. And let me show you the implications of these results. So let's go to the next sheet where we're going to bring in these standard deviations and express the confidence level that we have that we know the true value of this property. The conclusion of value was $105,000. But when we consider that the standard deviation could be, well, let's put in 1419, we see that the values actually are going to be higher or lower than that, depending on how confident we want to be in our result based on the standard deviation. If we wanted to be 60% confident, we would take 0.842 times the standard deviation, add it to our estimate for the high value, and subtract it for the low value. And this would be the range in which we are 60% confident that we know the true value. The true value lies between 103,805 and 106,195. If I went out one standard deviation, it would be 68% of the distribution, and the value would be 103,581 up to 106,419. Now that's a pretty tight range, and the reason is because this is a very low standard deviation. You see that we can go all the way up to 99% confident, and we're still in a pretty tight range, 101,339 up to 108,661. Let me show you what happens when I change that number to $10,000, which is just under 10% standard deviation for this kind of value estimate, and more typical, in fact, of what we actually see in the real world. In this case, if I wanted to be 60% confident, or let's say 68% confident that I knew what the value was, it would be somewhere between 95,000 and 115,000, and that would only be 68% of all the possible true values. If I went up to 70%, the value range expands. 80%, it expands. 90%, it expands. 95%, it's as low as 85,400 up to 124,600. Let me show it to you one more way. Let's take a look at this in terms of some slides. And let me illustrate the effect. So take a look at this normal distribution. If we go one standard deviation positive over our most probable estimate and one standard deviation negative, we get 68.2% of the distribution of the true values that are out there. And you can see if we go out two standard deviations, it's 95.4% of what's possible. Three standard deviations, it's 99.7% of what is possible. If we look at this distribution here, we see that this is a narrow distribution and this is a fatter one. This would be indicative of a very low standard deviation or a more normal standard deviation. And of course, it could be quite wide to the extent that we are uncertain about the value. If we go back to our $105,000 conclusion and we go out 68% in each direction using a standard deviation of just 1419, here's what happens. We know that with 68% confidence that the value in fact lies between 138,581 and 106,419. And we can continue that and see that it expands as we go to a higher confidence level. Let me show it to you one more time, but with a higher standard deviation. So now I increase the standard deviation to something that's more normal, $10,000, and I show you that I'm 68% confident that this property is actually worth something between $95,000 and $115,000. I'm 95% confident that it's worth $85,400 to $124,600. It's true that appraisers in general must come up with a conclusion of value, in this case, $105,000. But it's also true that we have tremendous value in knowing how certain we are about any particular value. So by using this methodology, we can show that in some cases, the confidence range is rather tight, and in some cases, it's rather wide in terms of knowing what the true value is. So this is really an important piece of information for lenders or buyers, because it tells them something about the uncertainty behind the value, and that information tells them a lot about risk. So I hope you appreciate this quick lesson on how to calculate a standard deviation and use that to get a range of value estimate in addition to a most probable number that we typically use for estimating market value. And I thank you for your attention.